Hi, I'm Shifik. I did this project for Cognee's Hackathon. So the name of the project is Dev Store, and so I'll get started with the introduction since it's a short video. So imagine you're on a call, a new feature launches 20 minutes ago, users are reporting failures. And the first question is like, what changed, what depends on it, and who owns it? So that's the problem Cognee Dev Store is trying to solve. So instead of forcing engineers to manually trace code during an incident, DevStore turns codes into graph memory before production breaks. So this is Cognee DevStore, a hackathon MVP for incident-aware code-based memory. So I'll talk about each of the things that's on the screen right now. So let's jump into it. So the idea is simple, like every PR should leave behind operational memory. So now I'll analyze the baseline. So I'm using a banking API to get balance and deduct money since I wanted to keep the demo short and sweet. So and it's like an easiest thing to do right now. So I'll just click analyze baseline, and if you see, the baseline is generated from what exists in the code base right now. And the important thing to watch is like how the graph changes from the existing system when I add a new PR. So let's say I analyze the feature PR. So the feature PR is basically nothing but adding a new API send money, which depends on both these API get balance and deduct money. So if you see, um, so first I analyze the production. So this is a stable system now. So so now let's so yeah. If I clicked on analyze PR, so so to do that, it checks the balance, deducts money as I said, and records the transfer and touches the shared wallet ledger part. If you see here, but so if you see here, there is a confirm edges option, which means that these are suggestions, not silent write. So the developer still has to confirm the edges because graph memory is only useful if it's trustworthy. So now I'll click confirm selected edges, and now the confirmed edges have become operational memory. So if Cognee is connected, which we can see over here, Cognee is still connected. So this will sync the memories to the Cognee cloud. So now I'll touch upon the incident like very quickly. So let's say the feature is live now and suddenly transfers start failing. So I run the incident query like failed send many transfers after friend payment plans. So I run the triage. Now if you see all the incident APIs got highlighted in red. So the read balance applied debit record transfer in the wallet ledger. So it is highlighting the blast radius basically. So if you see over here, it gives us an incident console. So in order of the highest probability of what went wrong first. So send money now depends on both balance and debit APIs. So the live analyzer found send money edges to get balance and deduct money. So the wallet ledger might have some idempotency conflict. So this is how I am using cognitive recall to get okay. So what was in the graph and then what could have went wrong. So this is so instead of starting from zero, the on-call engineer immediately sees like the dependency path, the owner, and the next actions. And now the current versus future. So this is just an MVP. The graph is generated from deterministic depth store connotations, or sorry, annotations, which makes their demo reliable and transparent. So the future version would replace annotations with static analysis plus an LLM that scans the real PI code and suggests nodes and edges automatically. But the confirmation step always has like a developer's say on it. So the LLM should suggest graph changes, not silently write them. So and the closing. So I will say that the core idea is that every PR should leave some kind of useful operational memory. And Cognee DevStore actually captures that dependency context when the developers still have it, stores it in Cognee and makes it available when the next production break happens. So that is Cognee DevStore turning changes into incident ready memory graph. So this was the demo. Thank you.